Okay, so far we've dealt with solving equations, and now we're going to look at inequalities that have greater than, less than, and greater than or equal to, or less than or equal to, and our goal is to solve them and analyze them graphically and algebraically. So one of the things that is important about inequalities is that they relate a lot back to equations, but something happens with the inequality sign when you multiply or divide by a negative. So for example, we're looking at 2x plus 3 greater than 7, which looks a lot like an equation except it has a greater than sign. So the key thing to remember is for inequalities, again, when you multiply or divide by a negative number, it flips the inequality sign, and we want to know why that happens. So let's analyze this inequality, this true statement that says 2 is less than 3. 2 is less than 3 is true. If I multiply both sides by a 4, I'm going to get 2 times 4, which is 8, and 3 times 4, which is 12. And notice the inequality stays still as 8 is less than 12. Multiplying both sides by a positive number didn't really do anything. It kept the inequality the same. Now let's take the same thing over here. 2 is less than 3, and I'm going to multiply both sides by a negative 4. I'm going to get a negative 8 on this side and a negative 12 on this side. Now which one's bigger, negative 8 or negative 12? Well, if you look at your real number line, negative 8 is closer to 0 than negative 12, so negative 8 is bigger, and watch what happened, the inequality flipped. So whenever you multiply or divide by a negative number, and the same thing would be true if I divided by a negative 2 or negative 4, or whatever negative number you want, the inequality would flip. So the key thing is to remember that when you multiply or divide by a negative, the inequality flips. Now let's look at these three examples to analyze what happens when you divide by a negative or multiply by a negative. In part A, I have this inequality, and I'm going to solve by isolating the x like I do for an equation. And when I do that, right here, I divide both sides by a positive number, so I don't have to worry about anything. X is greater than 2, and that's my answer. Now in part B, I do the same thing. I go about my business trying to isolate x, and notice here I personally divided by a negative number. I'm the one who said divide by a negative 2, and in the process I flipped the inequality, and my answer is x is less than negative 2. Now part C again, similar problem. I isolate x, and my last step is to divide by 2. Now even though there's a negative number on this side, I don't care because I personally did not divide by a negative 2. I divided by a positive 2, so the inequality remains the same. Again, make sure you know this. When you divide by a negative yourself, that's when you flip the inequality. When you divide by a positive 2, like we did in parts A and C, the inequality does not flip and it stays the same. Now another thing you want to be used to is what set notation is, or set builder notation. If x is greater than 2, there's a notation where we write brace x big bar, which means such that x is greater than 2. So whenever it says give the solution in set notation, you have to enclose it in this notation of brace x bar, and then just pop down your solution next to it. It says x such that all of this gets satisfied. Same thing for part B. Set notation would be x such that all of that gets satisfied. And you of course use appropriate variable. If this were like a z, you would use the letter z. X such that all of this gets satisfied. So those are my solutions in set notation. Okay, last one. Let's say I want to isolate x here and solve this inequality by subtracting 1 first. If I do that, I get 8 is less than or equal to negative 2/3 x. Now if you want to get rid of the fraction, you would multiply maybe both sides by a 3 first and then divide by negative 2, or sometimes if you want to get it all done in one step, you would multiply both sides by the reciprocal. So I'm going to multiply both sides by negative 3/2 And again, when I do that, these guys divide out, these guys divide out, and these guys become positive. So I end up with x only left. And on this side, this is an 8 over 1, so I'm going to end up with, if I reduce it 4 and 1, negative 12. Now be careful, because this is where the mistake often happens. I don't keep the inequality the way it is. I have to flip it, because I multiplied by a negative 3/2. When I multiply both sides by a negative, I must flip the inequality. So my solution is x such that I don't want to copy it in this version. I want to have the x on the left and the negative 12 on the right to have it in set notation. X comes first. So I put the x and I put the negative 12, and then I go back to what my solution was, and I see that the mouth opened towards the negative 12. So I open the mouth towards negative 12 to preserve what I had as a solution here.